Yeah.
Okay. All right. I'll put this up somewhere. Maybe get Long and put it up on his YouTube channel.
Awesome. Yeah,
Um,
that's great.
Excuse me, please. All right. Um, Everyone still see everything?
Yes, sir.
Okay. So for the lab this week, it's kind of similar to Lab '08, but as you can see, it's different. And so, similar concept, we're going to load a hexadecimal number into a register. We're going to initialize a counter into a different register, but then we're going to use these three commands in our loop. And what this asterisk with the brackets around it means is that it means you're going to need a little extra something there to get the job done. And so I want to go over, and so, a lot like last week, load a hexadecimal in. It's going to be sitting there in binary. We want to count how many ones and zeros. So I was looking at this lab earlier, and I want to just like go over like a key difference in understanding or something that a lot of you might be confused about. So everybody knows that you can put something back here like LE or EQ and roughly we know how it works because I've explained it before. But I don't think I've clearly explained the difference between how S is different than a condition flag. And so when you use the command like CMP compare, what it does is it compares the two, and then it goes and it sets one of the condition flags, which can be any one of these. These are the condition flags. Okay. S is not a condition flag. What S does is it will take a regular command like move, and it will go set a condition flag. Basically, S is like a switch where you're telling ARM to go set the condition flags for this command when I call S. And so, for instance, CMP has an implicit S when you use it because it will automatically, you don't ever see CMP-S because CMP is already going and setting a condition flag. But when you use move-S, you can use move with S or without S. When you use move without the S, it functions as normal. It just initializes whatever number you want. When you use S, what it does is every command has its own distinct behavior when you call S in conjunction with it. And so I might send these links out later, but it's all from this same website that he sent out right here. But for instance, you can see LSR is one of the commands that we need to use. LSR has its own functionality with S. So if you use it without S, it's not going to go set any condition flags. If you use S, we have to go look up this page and it'll tell you the behavior. It might set all of the flags. It might set none of them. It might set some of them. And so that's how you're going to get the information that you need to complete this lab. And then I can do like another one on Saturday and Sunday if we still have questions. But I want y'all to try it out on your own. And so you can see it's all in the same link that he sent out. All condition suffixes, and a lot of the things I just explained are in here. But the assignment is essentially, we're doing the same thing as last week. We're iterating on a register and counting how many ones there are. But we're doing it a different way. And now you have to use these commands in conjunction with S and some of these condition codes, which is not that this is a condition flag, okay? So how it works is either you can use CMP, well, you can't use CMP in this lab, but when you use S in conjunction with the command, based on the behavior described in the documentation, it will go and set the flags according to some value. So you can look in, crap, my Zoom's getting in the way. Okay. You can look at a table. I don't know where it went. I had it up. Here we go. So this is a table that tells you how the suffix will react based on what flag setting. So like if you call CMP, CMP has an implicit S. So it'll set some of these flags to basic variables. And you can read about which flag means what, you know, over, dang, I lost the page, like right here. So like if you do move S and the results of the operation is 0, then move S will go and set Z to 1. Otherwise, it'll be 0. And so the vocabulary that's used here is when a register is, quote, set, that means it's 1. When it's cleared, that means it's 0. So I don't know, that's a weird way to me to describe it, but that's what they're doing. Right over here, you can see Z is set. Okay, Z is 1. That's what that means. Okay, Z is clear, Z is 0. And so this is the behavior of this suffix in conjunction with this flag state. And so, yeah, I think I'll send some of the more important pages out in an email later on. But it's all contained, you can navigate there through the link in the PDF, and it's all contained right here. You're going to want to look up certain commands and figure out what they do. But that's all I have for today. And that's basically the information you need to at least figure out how it works. And so this code right here is kind of like last week. You can take it verbatim, but the loop, you're going to need to rearrange a little bit. So like, if you have a loop, so for the question for lab 9, that was an in-person lab with the Raspberry Pi, and typically like you have to come do it in a lab. So unfortunately, we're gonna have to skip it. Obviously due to current circumstances. So because you have a loop, you can imagine where this B needs to go. There's a certain command that I'm highlighting right now that needs to go at the end of every loop. And you'll branch back up to the top. It'll be a loop from 3 to 5. And so you need to arrange the loop in the proper order. I think all you need to do is move this B to the right spot, and then use the proper suffixes to get the job done. And you're going to need to use S in conjunction with a couple of these. And so we'll stop there. I'll get Long to post the video either today or tomorrow. And if we still have questions or can't figure it out, then I'll do another one on Sunday or Saturday. Are there any questions right now. How many more labs left? I don't know. I have to check. I don't know. I think when I took the class, there was 12 total. I don't know if he's going to add another one to replace, but we had the interactive lab. So I don't know if he's going to add one to replace the one that we skipped or not. I'll have to talk to Professor Long about that. Anything else? All right. Well, I'm going to go ahead and end the video. If you guys, if you end up if you can't figure it out by Saturday morning, mid Saturday, send me an email. And if I get even one email, then I'll host another session. The exam grades, I'm almost done grading them. But he does a lot of kind of like, it depends upon Professor Long's schedule because he gives out the final scores, and I don't calculate the curve. I just calculate the raw score. So once I'm finished, which should be by the weekend, I'll be done. Then it'll be up to, depending upon Professor Long's schedule, how long it takes him to, do whatever math he does to calculate the curve, if any. So I haven't graded all the problems. It's not bad. Some questions, I think they range everywhere. We split the questions up. So the questions I've done, I think the lowest was like a 60 people got, but then the highest on the other end, there was somewhere almost, it was 92% got it. So I would say probably just as a ballpark, it seems like around 78 or 80 is the raw score from the questions that I've looked at. It's not it doesn't look like people are bombing it, super hard. Looks like pretty standard computer science scores, 78, 80 from what I've seen. Any other questions? But don't quote me on that because I'm not done grading it, and that's just totally off the top of my head. So, all right. Well, good luck. Send me an email if you have any questions. And if you can't get it figured out, probably do another one this weekend. And so I'll send out more details on that. Y'all have a good rest of your week.